Welcome back, fellow learners. In this video, we will be completing the last section of June 2024, Paper 1, Chemistry, Ordinary Level 0515. We will be starting from question number 33. So, if you haven't subscribed to my channel, please kindly take some time and subscribe so that you can have subsequent videos. Thank you. Question 33. From 33 to 34, the instruction reads: each of the following questions consists of a statement in the left-hand column followed by a second statement in the right-hand column. Decide whether each of the statements is true or false. Then, on your answer sheet, choose A if the statements are true and the second statement is correct, is a correct explanation of the first statement. I choose option B if both statements are true, but the second statement is not the correct explanation of the first. Option C if the first statement is true, but the second statement is false. And option D if the first statement is false, but the second option is true. Okay, based on these, on the summary, that's how you will see it on your exam paper. When you follow that, you will try to go through the explanation to see whether they correspond to what the first statement correspond to the second statement, or they don't correspond, and you look at the answer choices and choose the right option. Let's go directly to the question. Question number 33 reads: dilute hydrochloric acid completely ionizes in solution. That's the first statement. The second statement: hydrochloric acid is a strong acid. Yes, it is true. Hydrochloric acid is true. The explanation from this from the answer is the explanation is a correct explanation of the first. But if it would have been reversed, I would have loved it. What are strong acids? Strong acids, according to Arrhenius equation, strong acids are acids that, when dissolved in water, they ionize completely. So when an acid ionizes in water by donating all its protons, in other words, we call protons hydrogen ion. By donating all its protons, we call them strong acids. So question number 33 is true, and it will be A. 33 is A, because the option is right. Only strong acids will ionize completely. Only strong acid will ionize completely. So hydrochloric acid is a strong acid because it ionizes completely. So it is true. A, and the second statement is a correct explanation of the first. So I say A is right. A is right. Then it takes us to the 34th question. The mass of an element. The first statement says the mass of an element liberated at the electrode during electrolysis is directly proportional to the quantity of electricity passed. Yes. But let me see the second statement. Oxygen is liberated at the anode during the electrolysis of acidified water. Oh, this statement is right, but it is not giving a right explanation of what has been given here. This is talking of the mass of an element. The mass of an element liberated at the electrodes. It could be on the anode or it could be on the cathode. But this one is somehow specific and totally out. It's not even talking about the mass. It's not talking about what is released at the anode. So this is not a correct explanation. And in that case, we say option B is the right one. The second statement is not the right one, so option B. Question number 35, 35. Question 35. The sodium ion has electron configuration 281, 28, 282, and 283. Okay. The sodium ion has electron configuration. Using the Bohr model is the model we use in the Bohr model. This is the Bohr model. Let me show it to you. This is the Bohr model. The Bohr model of an atom is represented like this. We have the nucleus, which is sodium. Let's say this is sodium. So electrons are arranged in orbits around the nucleus. So let's say sodium. Sodium has an atomic number of 11. We have one. The first shell has 2 electrons. Yes, the first shell has 2 electrons. The second shell will definitely have 8 electrons. Making a total of 10. And the last shell has 1 electron. This is the Bohr model of the Bohr model. This is the Bohr model of representing electrons in orbitals, representing electrons in shells. But now, electron configuration of this one is, the first shell contains 2 electrons, so we have 2. The second shell has 8, so we have 8. And the third shell contains 1, making a total of 11. This is a sodium atom that is neutral, a neutral atom for sodium, which is 11. But now, if sodium is having sodium ion, we are talking about sodium ion. Sodium ion implies that 1 electron has been lost. So sodium ion means 1 electron has been lost. Either is this electron that has been donated to maybe for bonding. So now sodium ion will definitely have what? Because when you lose an electron, you acquire a positive charge. Why do I say when you lose an electron, you acquire a positive charge? Because in the nucleus of sodium atom, we have 11 protons, which are positively charged. We have 11 protons, which are positively charged, and we have 11 electrons, which are negatively charged. So when 1 electron is taken, from there, we will now have what we call, we will have 10 electrons. We will have 10 electrons here. So our total number will be 10 electrons left. But for an atom to be neutral, the proton must neutralize the electrons. But it has come to a realization that we have more protons than electrons after one electron has been lost. So now, when we add this, there's going to be an extra positive charge. It is that positive charge that goes to reinforce the nuclear attraction, and that is the positive charge that is on the sodium atom. So sodium has more protons than electrons. That is why it has a positive charge, because one electron has been lost. Therefore, if we are going to electron configuration, we will have only, according to the Bohr model, we will have only 2 and 8. We have 2 and 8, and we go back to our answer. We go back to our answer column. If we go back to our answer column, you will see that if we go back to our answer column, what we are going to find there will be question number 35 will be, our answer will be our answer will be 28. So 28 will be our right answer. So it's B. So question number 36. Which element is extracted by thermal reduction? After going through your syllables and treating all the different extraction of metals, the metal that is extracted by thermal reduction is the metal that is extracted by thermal reduction is copper. Metal that is extracted by thermal reduction is copper. Then, if we go to question number 37, question number 37 requires the calculation. Now we are going back again to the stoichiometry of the subject. Now, calculate the percentage by mass of nitrogen in ammonium nitrate. The relative molecular mass of ammonium nitrate has been given. So the percentage by mass of this, the percentage by mass is usually calculated by the formula. The formula is percentage by mass is given by as follows. The way to calculate percentage by mass, we can say percentage by mass. Percentage by mass. Percentage by mass is given as the mass of is given as mass of solid, mass of solid divided by mass of solution, the mass of solution, and times 100. So if we do this, and in that figure, nitrogen is, we have 2 nitrogen atoms there, which is 14 times 2, we have a 28. Yes, it's 28, yep. Then we have the molar mass of ammonium nitrate, they gave it as 80 gram per mole, times 100. We would definitely be having something like maybe 35%, something like that. And if we do that, we can go back to our answer column and check the corresponding answer that is there. That is a simple thing we can do. So on our answer column, what we can get is go through the answer column. We are going to find from the answer choices, we are going to find C as the appropriate answer for that. Question number 28. It reads, oh, Okay, please let me wipe this first. Okay, let's move on, please. Question number 38. It says, the relative atomic mass of an element can be defined as the mass of one atom of an element. No, relative to the mass of 12 grams of a carbon-12 isotope. The mass of substance in 1 mole of mass. The mass of one atom of an element relative to 1/12 the mass of carbon-12 atom. The mass of 6.02 times 10 atoms of carbon. No. If we look at it, you will really know how to define the relative atomic mass when you get to the high school. There, it is defined as the average mass of the atoms of that element relative to 1/12 the mass of a carbon-12 atom. Or you could define it as the mass, the relative atomic mass of an element, the mass of one atom of the element relative to 1/12 the mass of one carbon-12 atom. Relative mass of one atom relative to 1/12, the most important thing. 1/12, the most important thing. So here, if we go back to our definition, you will see that C is the best option here. So 38, C is the best option. 38, C is the best option for the answer that has been given there. Now, let's go to question number 29. Question number 29 reads, how many isomers does pentane have? Pentane, pentane, that's 29. Pentane is an alkane of 3 carbon atoms. It's an alkane, a pent. Pent means 5. So a 5 carbon atom, let me say, a 5 carbon atom will have a structure like this. A 5 carbon atom will have a structure like 1, 2, 3, 4, and 5. Yeah, these are the hydrogens there. These are the hydrogens that are attached there. Yeah, pentane. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, it can now form another isomer as isomer. What are isomers? The first thing you have to know what are isomers, and by now you should have known that. So you should be able to differentiate between isomers and isotopes. These are molecules that they have the same molecular formula but different structures. So now we have this molecule again could be arranged in this form. 1, 2, 3, 3. One branching here is a CH, you have to say CH3, and another branch here is CH3. Yeah, yep. This normal chain, we call it N-pentane. N-pentane. Pentane. Then this is a normal pentane. So this one is what we call what? From here, this is 1, and this is 2, and this is 3. We can call this 2,2-dimethyl. We can call it 2,2-dimethyl. What is the parent name? 1, 2, 3. 2,2-dimethyl propane. 2,2-dimethyl propane. So now, it's 2,2-dimethyl, because there are 2 methyl groups. So you see, have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's the same thing. Now there's another isomer that can come there again as another isomer can come there, which will only attach itself on this other side, which we will say We have 1, 2, 3, 4, a butane. 1, 2, 3. Okay, we have a butane there, which can maybe on the second position. Yes. Yeah. So with this one in this position here, with this one in this position here, 1, 2, 3, 4, 5. You can place this at this position. If you place it here, this is 1 carbon, 2 carbon, 3 carbon, 4 carbon. If we decide to name it from this direction, 1 carbon, 2 carbon, 3 carbon, and a 4 carbon. So if we place it here too, if we place it here, it is still a 2 carbon. If we place it here, it is still a 2 carbon. If we place it, it's still a 2 carbon. So this is another structure, and this is a methyl group attached to it. So 1, 2, 3, 4, 5. There are 5. So we call this 2 methyl, sorry, yeah, 2 methyl, 2 methyl. This is a 2. This is on the second position. 1, 2, 2 methyl. Then 1, 2, 3, 4. 2 methyl butane. It's 1, 2, 3, 4. And on the second position, we say it's a methyl group attached. On the second position, we say it's 2 methyl butane. But there were two here. So that's why it had 2, 2 dimethyl propane. So now, here, another structure of this could still exist in a cyclo form. Let me say for propane, let me see. Propane will have is 12 carbon. Pentane, 1, 2. Yes, pentane has this 1, 2, 3, 4. Pentane has 4 positions. So a cyclopentane will, because there will be a reduction in the number of hydrogen atoms. So that one is not necessary. It's not necessary. So possibly we have 1, 2, and 3 isomers resulting from pentane. We have 3 isomers resulting from pentane. Cyclopentane will not go. 3 isomers resulting from pentane will make our answer be our answer choice to be a B. So 39 is B. Now we go to number 40. Select the most appropriate method for preparing sodium sulfate. Sodium sulfate could be prepared. The most appropriate method you can prepare sodium sulfate is is through a neutralization reaction. A neutralization reaction is the most appropriate method that you can prepare that. So our answer here is C. Question 41. One of the factors that account for the preferential discharge of ions during electrolysis. Factors. You should know that ions in an electrolyte, for them to be discharged at the different electrodes, there are some certain things you have to take into consideration. Reactivity. You have to go. You should be, another thing you should be aware of before your exam is the reactivity series. The reactivity series. Which element is up and which one is down? Remember, the most reactive metals, they will displace those below. So in that case, the one that are below will be displaced. So the factor that would definitely account or be taken into consideration in electrolysis is the nature of the electrolyte. The nature of electrolyte. The nature of the electrodes. Nature of electrolyte is not really important. The type of ions is not really important. They will go to the appropriate, either to the anode or to the cathode. The charge of the ion is not very, very important, but the nature of electrodes. Electrodes that will not be reactive. That's why you see the graphite electrode is always very, very important in that. So the nature of electrode is what is taken that's given preferential treatment during the discharge. So C is the right answer. #41 is C. Then #42. Which of the following which of the following serves as the cathode in the manufacture of sodium hydroxide? In the manufacture of sodium hydroxide, which one will serve as a cathode? In the manufacture of sodium hydroxide, the cathode in sodium hydroxide, we don't use platinum, we don't use copper, we don't use graphite electrode, but we will use the mercury. Mercury is very, very good in the manufacture of sodium hydroxide. So option A is right. Which of the 43? Which of the following is a disadvantage of using soap? Well, you have been using soap in the manufacture of soap. You know the advantages and disadvantages. If you have studied the organic chemistry part of it, you should know that scum is. That's why most people will prefer by using a liquid soap. Liquid soap. They prefer using liquid soap in the bathroom than using the hard soap. Because of what? Soap produces a lot of scum that help to dirty the bath and even the container. So the question is, which of the following is a disadvantage of using soap? Of using soap, it is an excellent cleaner in soft water. No, that's not the advantage. We are talking of the disadvantage. It forms scum with hard water. That's what I was saying. That most people, they don't like to use it in their bath because it dirties the water. It dirties the white bath and any other container when you are using hard water. That is the disadvantage of it. And that's why most people will prefer but liquid soap. So B is the right option for that. It is non-toxic to aquatic life. No. It is a biodegradable. No, that's not what we want. So B is the right option. 44, we go to 44. 44 says the polymer made from hexane 1,6-diamine and hexane 1,6-dioic acid is nylon, terylene, polythene, perpex. Remember that 1,6-diamine, this is an amine with 2 amino groups. This is an amine with 2 amino groups. And dioic acid, this is an alkane tool with it's a carboxylic acid, a dicarboxylic acid. Just look at it here. You see, hexane 1,6-diamine. These are the amine groups. The amine groups on the 2 edges. When we say hexane, I mean it's an alkane with 6 carbon atoms. I can start numbering from here. This is the first carbon. This is the first carbon here, the second carbon, the third carbon, the fourth carbon, the fifth carbon, and the sixth carbon. So I can name it as hexane 1,6-diamine, because there are two amine groups. The same thing goes with this other one, hexane 1,6-dioic acid. Because of what? The acid group is located on the first and on the sixth carbon. And we say dioic because there are two acid groups that are there. We say diene because there are two amine that are there. So this compound could be represented for the purpose of your revision for your exam. Let me take time to explain this to you. Now, you could write this compound in this form. That compound, hexane 1,6-diamine could be written like this. These are the 6 atoms of carbon. We call them methylene groups. These are the 6 methylene group here in parentheses. And then these are the 2 amine groups. It could be written like this, or it could also be written like this. You could approximate, or you could represent the 6 methylene groups in this form as a box. You could write it like this, with the 2 functional groups at the edges, at the 1 and the 6th position. Secondly, representing the acid, hexane 1,6-dioic acid. This is the 4 methylene groups that are there. They are supposed to be 6, but the first carbon is here and the last carbon is already here. So that's why I represent it as 4. So the 2, this one here could be represented as a box, then with the 2 functional groups that are attached there, and it could be written in this format. You could write it like this. Now, when these two they react in forming a polymer, because the polymer formed from here is a condensation polymer. This is an addition polymer, but result in a condensation, result in a release of molecules of water. That's why we call it condensation. It's an addition polymer. We keep on adding hexane 1,6-diamine, hexane 1,6-dioic acid on each other. We call it addition polymerization, but it leads to a condensation. And in that case, when we add this, see the molecule up here. When we add this, what will happen is that the 2 functional groups, the amine functional group and the acid functional group, will interact, and a molecule of water will be released. This other one will interact. A molecule of water is what? Is H2O, 2 hydrogen and 1 oxygen, will be released, and a new bond is formed. So what is going to happen here is, if I represent this in this form, you will find that here, okay, this is the hexane 1,6-dioic acid. This is it here. This is the acid group here, and this is also the acid group here. On the other side, it is hexane 1,6-diamine. This is the amine group here on this side, and this is it on this other side. Well, this is a display structure. On this display structure, okay, I said a molecule of water is going to be released because it's a condensation reaction, though it's addition polymerization. The OH group of the carbon in the acid group, the OH group of the acid group, now will interact with one of the hydrogen from the amine, and a molecule of water is being released. The same thing will happen here. 1 hydrogen from the amine group and the OH group from the acid group will interact, and a molecule of water will be released. The same thing will continue here. The dotted lines I have put here, it shows how a hydrogen bond could be formed between the oxygen, the highly electronegative oxygen, and the hydrogen. So when that happens, a molecule of water is being released when the two functional groups are interacting. 2 functional groups interacting, a molecule of water is released. 2 functional groups interacting, a molecule of water is released. As we keep on adding as we keep on adding hexane 1,6-diamine, a molecule of water is being released. As we also add hexane 1,6-dioic acid, a molecule of water will also be released from the reaction between the amine group and the acid group, as you have seen here. This is how it is being represented. That's how the structure will go. So you could be given an exam to write or to dictate where there's a hydrogen bond or to dictate what is happening. This is how you can do. Then the resultant of this reaction here between hexane 1,6-dioic acid and hexane 1,6-diamine is what? There is a polymerization that is taking place. Water is released, and a polyamide is a polyamide because it's a combination between, a bond is formed between the carbon and the nitrogen. We call it a polyamide. Or another way we call it an amide linkage. Or we call it a peptide link. Either you call it the whole of this structure that result, we call it a polyamide, and that is what we call nylon. A polyamide is what we call nylon. So within the bonds, because in your exam they could draw it and ask you to label. So it is labeled as an amide linkage or a peptide link. Now you could see it like this in your exam. You could see it like this in your exam. This is it here. This is the 1,6 hexane 1,6-dioic acid. After releasing the water molecule, this is the keto group that is there. Now, then this is the hydrogen that is also there. This is the methylene group that I approximated them. All the carbon I approximated them to be like this, and left only the functional groups. So this is how you can equally find it in your exam. A polyamide. It will continue. The dotted line shows that the bond will continue forming as far as you are adding more hexane 1,6-dioic acid or more hexane 1,6-diamine. The bonds will continue, and that's a polypeptide, a polyamide that you are forming. And each time two functional group meet, there is a condensation, releasing a molecule of water. Let's go back. So a nylon is being formed. Let's go back to our answer page. Now on your answer page, we were on question number 44. The polymer made from hexane 1,6-diamine and hexane 1,6-dioic acid is a nylon. You don't need to go anywhere again. Don't go anywhere again. Okay? So the answer is A. Now let's go to question number 45. It has to do with calculation again. It has to do with calculation. Now on question number 45. Okay. On question number 45, we have to. Yep. Question 45 here, we have what is the concentration of the solution formed by dissolving 6 grams of sodium hydroxide in 250 cm cube or cubic centimeters of solution? Okay, we are now talking of trying to make solutions and try to calculate their concentration. By now, you should be aware of the formula to calculate the concentration. Concentration, another word for concentration is molar. The molar concentration. Concentration is given as mole per dm cube. Mole in dm cube. A certain amount, that is moles in dm cube. That is concentration, mole per dm cube. A certain amount of substance dissolved in 1,000 cubic centimeters, or in 1 dm cube of solution. That is the concentration. If you look at my previous video on how to prepare standard solutions, you will see them there. Go to the A-level section, you will see it. So now, question 45, how can we calculate the concentration? What is the concentration of the solution? Okay, you have been given the mass. From the mass, we can have the number of moles. Okay, from the volume, we can have our volume has been given in cubic centimeters. We can convert it into cubic decimeters. And when we do that, there is a formula we say concentration is equal to moles all over volume in cubic decimeter. From there, we'll have our concentration. Okay, briefly, just see what I have here for you. Okay, the moles of sodium that were given, they are 16. And in order to calculate the moles of sodium, we have mass, all of our molar mass, we have 16 grams of the mass that was given, divided by 40. 40 is 23 for sodium, 16 for oxygen, and 1 for hydrogen. Make a total of 40. And when we divide it and times by 1, we will have 0.4 moles. We are timesing by 1 because when we divide grams by grams, there will be no moles. So we put times 1 mole of sodium hydroxide. Then in the volume, volume in dm cube, we were given 250 cubic centimeters. When we divide it by 1,000, because we have to dissolve it in 1,000 ml. 1,000 ml is 1,000 cubic centimeters, which is the flask, the round bottom flask of 1,000 ml that we use in the laboratory in the preparation of standard solution. So when we divide 250 by this times 1 dm cube, it gives us 0.25 dm cube. Now, calculating the concentration, we have concentration as, this is the formula for that. Concentration, this is the formula that is for concentration. So the formula for concentration, you could write it in this way. That is the formula for calculating the concentration. Concentration is equal to moles divided by volume, and the volume should be in cubic decimeters. In that case, we already have the volume, we already have the number of moles that we calculated, and we already have our volume in dm cube, or cubic decimeter. So what we do is, dividing the number of moles by the volume will give us 1.6 molar. So molarity is a mole per dm cube, and that is the concentration. Secondly, in an exam room that you may not have time to do this, a simple way of doing this is concentration. You divide 16, you divide the mass all over the molar mass, times by 1 to cancel all the grams. Then you do what? You do 1,000 divided by 250 times 1 all over dm cube. You'll still have the same answer. When you have the data, collect the data first. The data is the mass that have been given, the molar mass that have been given, the volume that have been given. Then you place your data and do your manipulation, and you have the answer. Thank you. So the answer here is 1.6. And if we go to our answer column, We go to our answer choices. On question number 45, what are we going to get there? On our answer choices, question number 45 will be giving us 1.6 molar, which is answer choice B. Uh, 45 answer choice B. 46. The electronic I prefer calling it the electron configuration. The electron configuration of an element M. The electron configuration of an element M is 2A2. Identify the group to which M belongs. Fellow learners, you should know that, you should know your periodic table. The periodic table as arranged by Mendeleev shows everything. On the periodic table, Mendeleev arranged the periodic table 1 in order of increasing proton number. He also arranged them based on their reactivity, their properties. And with this, all elements that have the same property or similar properties were placed on one group. The only exception was the transition metals. That was a gap that was left there for what? For elements that were yet to be discovered. And now that they have been discovered, that's why it has been filled. So the periodic table is arranged in order of groups. That's running from top to bottom. Then from the other end, from the left to right, we call them the groups. And each group corresponds to the number of valence electrons. If you look at it on the periodic table, each group corresponds to number of the valence electron. For instance, the valence electron in group 1. Valence electrons, in other words, we call them the outermost electron, if we use the Bohr model in representing electron in shells. So the valence electron, or the outermost electron as it is called, these are the electrons that determine the group number. For example, elements in group 1 have 2 valence electrons, or have 2 outermost electrons. Group 1 have 1 outermost electron. Group 2, they have 2 outermost electrons. Group 3, they have 3 outermost electrons. Group 3 or group 13, as the modern periodic table calls it. Group 4 or group 14, group 4 has 4 valence electrons. Group 5, they have 5 valence electrons. Group 6 have 6 valence electrons. Group 7, that is the halogens, they have 7 valence electrons, or the outermost electrons. Group 8, they have a full octet of electrons. That's why we call them group 8 or group 0. So if we look at the periodic table we look at the electron configuration based on the Bohr model, 2 inner electrons, 8 electrons in other energy levels, and 2 outermost electrons or 2 valence electrons, it means the group to which M belongs is group 2. Because I said the groups are arranged based on the number of outermost electrons. Group 2 have 2 outermost electrons, or what we call valence electrons. So our answer for 46 is A. Our answer for 46 is A. Let's go to 47. 47. How does a catalyst increase the rate of a reaction? Well, I know you must have treated rate of chemical reaction. There are many factors that influence the rate of chemical reaction. We have the temperature, we have the catalyst, we have concentration, we have pressure in terms of gaseous reactions, and many others. But here we are talking about a catalyst. How do you think a catalyst is going to increase the rate of a chemical reaction. Remember that in that very reaction, at the end of the reaction, the catalyst is not consumed in the reaction. The catalyst is not used in the reaction. It doesn't take part in the chemical reaction, but there is a thing it does to increase the rate of reaction. Let me show you something here. For this reaction to go successfully, these are reactants. These are reactants. It's an exothermic reaction. These are reactants here. A normal reaction will definitely lead from here and right here to this, from here and right to the end, at the apex here. We call this place the activated complex. And from here to that place, we call it the activation energy. This is activation energy from here to the highest level. That's the energy required. Activation energy required, the minimum amount of energy required for a reaction to occur. Now, okay, this is a reaction that is not catalyzed. But when a catalyst is added, the catalyst is going to do what? It provides an alternative pathway for the reaction. And what is the alternative pathway? It lowers this activation energy. So this is the pathway. This is a pathway for the reaction. This is a pathway, it comes here, right here. So you now see that for a catalyzed reaction, it has a lower activation energy. So in that case, we can conclude that a catalyzed reaction, or a reaction where a catalyst is added, lowers the activation energy for the reaction. Let's get back to our answer choices. In our answer choices, how does a catalyst increase the rate of a reaction? 1. By decreasing the kinetic energy? No. Increasing the activation energy? No. By making the product more stable? No. By lowering the activation energy. That is the answer we got. When you lower the activation energy, instead of the reactant taking a lot of energy to overcome for a reaction to occur, it has a shorter energy, a lower activation energy, and the reaction occurs very fast. So in that case, we do what? It lowers activation energy. 47 is D. Let's go to 48. Number 48. Identify the homologous series with the general molecular formula CnH2n plus 2. Well, you know, you must have been doing this. Alkanes, they have a CnH2n plus 2. Alkenes, they have a CnH2n. Alkynes, they have a CnH2n minus 2. Alcohols, they have it plus 1, the OH plus 1. Alcohols, or what we call the alkanols, they have it. Carboxylic acid, they also have theirs. So we want to identify the homologous series that have CnH2n plus 2. These are the alkanes, and you can confirm it from here. These are the alkanes, and you can get it from here very well. This is how the alkanes are arranged. This is how the alkanes are arranged. Look at this example here. The alkanes, we have a CnH2n plus 2. I don't need the functional group, but what is there? This is the functional group 2. So what is, we have methane, ethane, propane, and butane. Well, in your exam, if you were given alkene, then this should be the functional group. If you were given alcohol or alkanols, then this should be the general formula for the homologous series. If you were given carboxylic acid, then this should be the general formula for the carboxylic acid. So you should know the one for alcohols, the general formula for carboxylic acid, alkenes, this one, and their functional groups as well. So here, our answer is alkane. Let's go back there and move on. Alkane, 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 alkane. So the homologous series with this is alkane. And we go to option number, is it A? Is it B? Yes. So 48 is B. Let's go to 49. The volume of a fixed mass of a gas is inversely proportional to pressure at constant temperature. Which law explains this behavior? The law, Charles' law, does not do that. It's directly proportional. Avogadro's law deals with molecules. Equal number of volume contain the same number of molecules. That's Avogadro's law. Dalton's law, Boyle's law, is inversely proportional. Boyle's law is inversely proportional. As the volume is increasing, the pressure is decreasing. As the pressure is increasing, the volume is decreasing. That is Boyle's law. So the volume of a fixed mass of gas is inversely proportional to its pressure, provided the temperature is constant. So P, V is inversely proportional to P. As the volume increases, the pressure decreases, and vice versa. So Boyle's law gives us that. So in that case, we go to Boyle's law, which is C. 49 is C. And the last one for today. Identify the raw material for the contact process. The contact process is the industrial manufacture for sulfuric acid. Of course, you know the raw materials. We will need sulfur dioxide. We will also need water, and we will also, those are the raw materials. Not the raw materials. You know that sulfur that results from volcanic eruption is the one that is used for the contact process. Oxygen is also used. So when we use sulfur and oxygen, a reaction takes place to produce sulfur dioxide at equilibrium. That's a reversible reaction under low temperature. Now, the sulfur dioxide is now reacted with oxygen again to form sulfur trioxide. We cannot use sulfur trioxide because they said identify the raw material. The raw material that we keep on doing that. So the raw material is sulfur, and the other one is sulfur, and the other one is oxygen. Sulfur trioxide is only a reaction of sulfur dioxide plus oxygen. So it's not sulfur trioxide is not a raw material. Sulfur is a raw material. Water is not a raw material. Sulfur dioxide is not a raw material. The raw material initially are sulfur and oxygen, and that gives us option C. And that gives us option C. Fellow learners, if you answer these questions like this, then I will be proud of you during your exams. Once more, go study your, you have to study your qualitative analysis, your stoichiometry, that's calculations, writing your balance equations. You need to study electrolysis well. You need to study organic compounds, their reactions, their products. You need to study more of the lab activities, the practical activities, reactions for the qualitative section, reaction for metal ions with aqueous sodium hydroxide, aqueous ammonia solution, aqueous silver nitrate solution. When they react with these, what will be the outcome? Then you also need to know reaction of silver nitrate, aqueous silver nitrate with chloride ions. What does it give? So with all this in place, and your periodic table, how elements are arranged in terms of group, in terms of periods, and their property. When you have this in place, and then I will be proud of you. Thank you once more for listening. If you haven't subscribed to my channel, please subscribe, and you will certainly be having the videos that are coming out. Have a nice day. Bye-bye.